Welcome you all to the course Database Management System. Myself, Mohammad Asifuddin Montal, Assistant Professor, Department of Computer Science and Engineering, Navla Institute of Technology. And this is lecture number 21. And in this lecture, I will discuss about the relational database design, chapter number 5. And these are the topics which I am going to cover during my lecture. I will discuss about relational database design guidelines, means the guideline which we should follow while designing a relational database, and then I will discuss about different anomalies that may present while inserting or updating a data in a database. So first I will discuss about the relational database guideline. So while making a relational database, we have to follow some guidelines. Basically 4 guidelines are there. If we follow these 4 guidelines, then we will come up with a good relational database design. And otherwise, if we don't follow these guidelines, then whatever the database we are going to design, that database is not the correct one. That means in that case, if we store the data and retrieve the data, then you cannot store and retrieve the data in an efficient manner. So to store the data and retrieve the data in an efficient manner, we have to design a good relational database. And for that, to design a good relational database, we have to follow 4 guidelines. So I will first discuss about the guideline 1, which we have to follow to come up with a good relational database. So guideline 1 basically is that don't combine the attributes from multiple entity types and relationship types into a single relation. That means in a single relation or in a single table, if we combine the attributes from different entity types and relationship type in a single relation, then that database design is not a good design. For example, suppose we have to create a database which is going to be store the information about their company's employee, then their corresponding department and their corresponding project where he or she is assigned. Suppose that means in that example 3 entity sets are there, 3 distinct entity sets are there. One is employee entity set, other one is the department entity set, and other one is the project entity set. Suppose the employee entity set has following attributes: social security number, then employee name, employee address, and date of birth. These are the attributes related to employee. Suppose department entity set have following attributes: suppose department number, department name, department location. And suppose project entity set have following attributes: project number, project name, and say for example project location. Now if we combine all these attributes of these 3 entity into a single table or in a single relation, then that design is not a good design. So you cannot combine the attributes from multiple entity types and relationship type into a single table or in a single relation. That means while designing a relational database, only you can only include the attributes which is related to a single entity. So only that attributes constitute a single table. So don't combine the attributes from multiple entity type into a single table. This is the vital point. For example, graphically if we see that, for example, employee name, SSN is the social security number. SSN means each employee has unique social security number, that is why it's called primary key. B date means the birth date of the employee, address of the employee, and D number is the department number where a particular employee belongs. Now if you look at that table, so employee name SSN, birth date and address. These are the attributes which basically belongs to the employee entity set. Means again I am repeating, employee name, SSN, birth date and address. These four attribute belongs to the employee entity set. These four attribute belongs to the employee entity set. That means while designing a database, the employee these four entity set should be included into a separate relation, and the relation name should be meaningful as it stores the information related to employee. So the name should be employee, the name of the relation should be employee. And while storing the department information, definitely we need to create another separate relation, and name of the relation is department, where we should include the attributes which is related to department only. As we know, in the department relation, it has the following attributes: department name, department number, and DMGR underscore SSN means department manager SSN. So all these three basically belongs to the department entity set. So these three corresponds to basically department entity set. And to make a relationship between employee and department, so employee is a distinct entity set, department is a distinct entity set, but they have some kind of relationship. So to establish a relationship, we have to use the foreign key, which I have already discussed in my previous lecture. So with the help of foreign key, we can establish a relationship between employee and department. So D number, which is the primary key of department, is included into the employee entity set, and it becomes foreign key. So with the help of foreign key department number, we will be able to establish a link between employee and department. For example, suppose SSN social security number is 1, employee name is Rahul, date of birth 5th January 1990, address say Kolkata, department number is 10, and the corresponding department number 10, that department information is stored in another relation. So department number 10, department name is software developer, and DMGR SSN is 100. So you can track which employee works in which department if you combine the information from employee and department. So what I am going to highlight is that in employee relation, it includes only the attribute which is related to employee. In the department relation, you have to include only those attributes which is related to department. Now, apart from that, you may include an attribute from other entity type only for establishing a link. In that case, department number definitely is not related to employee, but again we have to include the department number attribute to the employee relation, as because to establish a link between the relation employee and the department. Similarly, we are breaking up the department relation with further that department location into a separate table. So department location, and you have to include the foreign key department number. So here the department number is the primary key, so that primary key we are including in another relation, and it becomes foreign key. So you can establish a link between department and department location also. And our objective is to store also project information also. So project have following attributes: project number, which is the primary key, which is unique for every project, then project name, then project location, and then department name. I mean, DNAM is basically department number. So here project number is the primary key. Now that particular project belongs to which department, so you have to establish a link between project and department also. For that again we have to use the foreign key. Here department number is the primary key, that attribute should be included over here as a foreign key. So a particular project name which have a particular project number belongs to a project location and whose project belongs to a particular department number. And department number, from department number, if you look at the department table, we will be able to get which department it is. That means, again, the bottom line is that only include those attributes in a relation which is related to only that specific entity set only. In that example, if you look at the project relation, in the project relation, P name means the project name, P number is the project number, and P location, these three attribute is strictly related to the project entity set or the project relation only. Again, I am repeating, P name, P number, and P location, these three attributes are related to only project relation or project entity. So in the project relation, no other attributes are included, only we have included dnum. Why we have included dnum? Dnum basically d number, to establish a relationship between project and department relation, so that we can track a particular project name which belongs to in which department with the help of this foreign key. Now, before discussing the guideline 2 of relational database design, we have to discuss different kind of database anomalies. The big and the common database problem is that if we design the database without following any guideline, then we will come up with a poor database design, and poor database design have redundant information. Now, redundant information or the redundancy means repetition of same information in multiple file. Here the file means same information may be repeated in multiple relation, or same information repeated multiple times in a single relation. So that means in a single word, redundancy means repetition of information in several places. So redundancy will appear in a database if we don't follow the design guideline. And there are several consequences of data redundancy. The first consequences or the first problem is wastage of storage, means if same information repeated in multiple places which is at all not required. So if same information repeated multiple places, so it consumes much more memory, so it is a kind of wastage of storage. The other consequences is it creates or it leads to a update anomaly. It leads to a database update anomaly. Now, anomalies means undesirable situation which may arise in a database while updating the database. For example, three kinds of anomaly mainly occurs: insertion anomaly, deletion anomalies, and modification anomalies. We will discuss all these three in this lecture. So first we will discuss example of update anomaly. Now, what is update anomaly? While updating a database or while updating a relation, if some kind of anomalies happen, then that is known as update anomalies. Consider the relation. The name of the relation or name of the table is emp_prog, means employee project, which constitute with the following attributes: employee number, project number, employee name, project name, and number of hours. Now, the first question is that whether this database, this relation emp_project is a good design. Is it a good database design or bad design? Already we have learned what is guideline 1. The guideline 1 states that do not combine the attributes from multiple entity types into a single relation. But in that single relation, we are combining the attributes from two entity types: employee number, employee name. These two belongs to employee entity, whereas project number, project name and number of hours, these three basically belongs to the project entity or the project relation. That means in a single relation we are combining the attributes from employee relation as well as project relation. That is, this design of that particular database is not following the guideline 1, it is violating the guideline 1. So that design is not a good design and it leads to anomaly. So first anomaly, the first problem is update anomaly. For example, project number is P1, P1 is the project number, and initially in the project number the name of the project is billing. Again I am repeating, the project number is P1 and project name, suppose it's billing, and assume that in the project number P1 whose project name is billing, this one billing, suppose 100 employee works on that. That means suppose the employee 1, project 1, employee name Rahul, project name billing, number of hours. Similarly, project 1, another employee works and project name is billing. That means in a particular project P1, project name is billing, suppose 100 employee works. So 100 information will be stored against a single project P1. And other project also may be there, project 2, project name is testing, whatever it be. But the problem is that if we want to change the name of the project whose project number is P1 from billing to customer accounting, suppose the project name has changed from billing to customer accounting for project number P1. So initially the project initially the name of the project of project 1 was billing. Now the name of the project is become customer accounting. So what we have to do, we have to update all the 100 employee who works on project 1. So if we forget to update all the 100, if we forget to update all the 100 employees information, then it will produce an update anomaly. That means once the project name is changed from billing to customer accounting for a project number 1, so we have to update all the employees record for which they works on project number 1. If we forget any one of the employees information who works in project 1, then database will be in inconsistent state, no actual state will be reflected. So this is known as update anomalies. Next, delete anomaly. Delete anomaly means while deleting a record, then database will become inconsistent and undesirable situation may occur, and that kind of anomaly is known as delete anomaly. Consider the relation emp underscore proj, which constitute with the following attributes: employee number, project number, employee name, project name and number of hours. Again this relation is violating the guideline 1. So this is a bad design and due to that it leads to a delete anomaly. Now what is delete anomaly? We'll explain it with an example. Suppose a particular project, suppose project number is P1 and suppose project name of the project is say X, and in the project X suppose 100 employee works on that project X whose project number is P1. Suppose the project X is completed, is done, so it is no longer required to store that project information. So project X is complete, no longer required to retain that project X information in that relation. So what we have to do, we have to delete the record. Now as we know, we can delete a total record, we cannot delete a particular value against a particular attribute. We can delete a total record, you cannot delete a value against a particular attribute. So if you delete then total record will be deleted. So if we want to delete the record which project name is X, then all the 100 employees information is also going to be deleted. That means, again I'm repeating, if we want to delete the project information whose project name is X, that means all the 100 employee who works in that particular project X, all the 100 employees information is also be deleted along with the information of project. That means if we delete a particular project information, then we will be subsequently lost the information of all the employee who works on that particular project, and this is very undesirable situation in any database. And alternatively, if an employee is the only one employee, that means if an employee is the sole employee or the only one employee on any particular project, then what happens? Suppose particular employee number is 1, employee name is Rahul, who works in project X, and assume that the project X has only one employee, that means only one employee works on that particular project. And suppose that the employee has left his job, resigned from his job, leaves the company. That means the company no longer need to retain the employee's information. So company, what we have to do, we have to delete that particular employee's information, and again same situation happen, we can delete whole record. So once we delete that particular employee's record, means whose employee name is 1, if we delete that record, then whole record will be deleted. Once employee's record is deleted, subsequently his or her corresponding project information is also be deleted. That means once the particular employee whose employee number is 1, employee name is Rahul, who works in the project X, and in that project X only that particular employee works. So if we delete the record, whole record will be deleted. So if someone look at the database, he or she will see that there is no project X, there is no project X in that database, but actually in reality project X is running in the company, but database shows that no project X is there. So that kind of undesirable situation is known as delete anomaly or deletion anomaly. So these are the database. Already I have discussed all this. If you consider the relation, again just recapping it, suppose this is the relation emp underscore dept. That relation contains the following attributes: employee name, social security number, SSN, birth date, address. Now these four basically the attributes from entity employee. So employee name, SSN, birth date, address, these four attributes are related to employee, and department number, department name, and DMGR SSN, these three attributes actually related to department relation or department entity. But here what we have done, we have combined the attributes from multiple entity types. This is the attributes from EMP entity, these are the attributes from department entity, and we are combining all together in a single relation. So this is bad design, and if we design like that way, then it will face insertion, deletion, and updation anomaly. So we have to separate it. How to separate it? We have to design a relation whose name should be EMP, which should contain employee name, social security number, birth date, address, and department number, where SSN is the primary key and department number is the foreign key. And then create another separate relation DEPT, which should include department number, department name, and DMGR SSN. And here department number is the primary key. And then this is your task. You have to decide whether that particular relation is following the guideline 1 or not following the guideline 1, is violating the guideline 1. And now look at the database, which I have already discussed. If you go to the previous slide, this one, this is the database design of EMP underscore DPT, and this is the suppose state of the EMP department, current state of database EMP underscore DPT. These are the records stored in EMP DPT. Now, if you look at how redundancy are occurring in the bad database design, look at, suppose the department number is 5, department name is research, and DMGRSSN is this one. Now suppose in the research department 1, 2, 3, 4, 4 employees works. Let me highlight the records. So research, so department number 5, research, 5 employees works. This one 1, 2, 3, 4. So these 4 employees works. So what happened? The redundancy for this 5 employee, the 5 research DMGRSSN, 5 research, then 3, this set of information are repeated multiple times. How many times? For 5 employee, same information is repeated 5 times. So if there is 100 employees, so 5 research 333 44 5555, so this set of information will be repeated 100 times. So it will be repeated as many employee are there in a particular database. So that means this portion is redundant information. And why it is happened? Because we are designing the database by combining the multiple attribute type into a single relation. Now if we break down the relation EMP underscore DPT, so employee name, SSN, birth date and address, and department number, and make another separate relation with department number, department DM, MGISS, and what happened? Only in the separate relation it will looks like that. So this is the DPT relation, means we have to separate the attributes of different entity into a separate relation. This part belongs to EMP and this part belongs to DPT. So if you look at the table DPT, 5 research and the 5 department number, department name research, and corresponding DMGRSSN is only one entry is there. For department number 4, department name administration, corresponding DMGRSSN is only once. So that here the information is total information is not repeated multiple times, only single instance are there. So in that relation EMP underscore DPT, this set of information is repeated multiple times. Why? Because it is combine the attributes from different entities. Once it is removed from the original relation, the redundancy disappears from the relation. So next is design guideline 2. Design guideline 2 is that design a relational schema so that it does not suffer from insertion, deletion, and updation anomalies. And if there are any such kind of anomalies are present in there, then note them carefully so that application can be made to take them into an account. Next, the guideline 3. Now guideline 3 states that don't place the attributes into a relational database whose value may frequently be null. That means while designing a relational database, those don't include those attributes whose value may frequently appear as a null value. So that means attributes that are more frequently be null could be placed in a separate relation. Don't include them in the original relation. Try to avoid include those attributes whose value frequently be null. For example, suppose the office number, the cabin number attribute, its office number is the attribute of EMP relation, and the thing is that not all employee have assigned office or assigned cabin. So what happen if you include the office number, the cabin number in the employee relation? For most of the employee, the cabin number, as they have no cabins as specific assigned cabin or the office, so they don't have the office number, not has the cabin number. So in that case, the corresponding office number or the cabin number attribute becomes null. So the null value will appear for most of the employee. So it is not desirable to include such kind of attribute in your relation. And null means, already we know what is null: attribute not applicable or invalid, attribute value is unknown, that means the value attribute value is not exist, or its value is known to exist but unavailable currently. And design guideline 4, another guideline is there, design guideline 4. I will discuss it in my next lecture, and these are the references you may go through for more details about relational database design.